All right. So we have our instructions here that'll help us if we fall behind or whatever. But for this project, we're going to make that Space Invader game. Sometimes it's called an avoidance game. Hopefully many of you are kind of familiar with these kind of games. As an example, we can bring up an example actually. So let me bring up an example from a past semester of what it looks like. So actually Andrew made a really awesome game last spring. And we can add in sound and everything. His has some sound. So he made his for his final project as well, so he went a little bit above and beyond kind of what we did, but this is what you can do with this type of game. Okay, so we did a little bit of polymorphism, and we can do that in here, where we can change our player. Okay, so we can have multiple players you can choose from. And then we'll learn about polymorphism, okay, which is a good programming concept to get acquainted with. And then we have our start button. He did have a level and a score. He made those positive green things that actually give you like different kinds of powers. And then he actually did make levels in his game. And then he used a scrolling background. We'll learn how to do the scrolling background today. Oh. And then if those little bad guys get past you or they hit you, then they give you negative points. Oh yeah, there's one of his better guns that he had. So if you get those little green things. Oh, I think I ran out of bullets. Oh, a barrier. He made a barrier. So Andrew made that game. Let's look at a different one. It's actually pretty fun. And then here's one that's a little bit more simple. Oh, he uploaded it. Here it is. So he used, you know, you could choose either one of these players here. So then he made a little explosions and things. Okay, we kind of get the idea. So you're shooting upward, you're moving your player back and forth, and then when you hit the bad guys, they explode and you get points. So, kind of a fun game. And you can do your own theme. In fact, let me look at Neon Mason's. Where's Mason? She did a little bit different of a theme. Here we are. So you have to choose a little girl or a kitty cat. So you don't have to choose. And then it shoots hearts up at the little boys. So then she did make them explode. I always thought that one was kind of funny. Okay, but those are some examples of some games that, you know, that we can make. So you can choose any kind of theme, you know. And it's pretty fun. All right, so we're ready to get started, and we're gonna do like how we've been doing. We'll design lots of our characters in the FLA file, and then we're going to write our programming code in our AS file. So like we've been doing. All right. And remember, we have our instructions here too online. So first things first, we're going to make a new FLA document. We are then going to make a new player object. That's going to be our player. And then for now, just so we can get the programming out of the way, we can just make him a rectangle. And then you can exchange him for a better player after. It's pretty easy to do. And then we'll make him a movie clip symbol. We'll export him for ActionScript. And then we'll start in on our AS file and test it. Okay? So let's start with a new ActionScript 3.0 file. Okay, if you haven't already. First things first, let's go ahead and save him. Remember where you're saving him. And you can call him what you want. I think this time around I'm going to call him Space Invaders. And then for the properties for my stage, I'm going to go ahead and make the background black. Now, I'm going to add a scrolling background later, but just for now, I'm just going to make a black background. So remember, if you click off everything on your stage, you can get a hold of your stage. And I'm going to go ahead and change his size of my stage to something that's a little bit better for my E-pad. I'm going to change it to 800 by 550 right up front. Remember that you can change this later, or you can change it to fit your phone or whatever device you're running it on. Okay, but it's good to kind of figure that out up front. So I made it 800 by 550. Alright, now we'll draw our player out. I'm just going to use a rectangle tool. I don't want my rectangle to be black, so remember when you click on your rectangle tool, the properties for that tool pop up in your properties panel. And you could choose a different color other than black so then we can actually see him. And just choose no stroke color. Remember, no stroke color is that white box with the red line through it. And we'll just draw, you know, a player here on the stage. Doesn't have to be anything special because we're going to exchange him later for a better looking player. After you create him, go ahead and click on him and then make him into a symbol. And everybody should know how to make him into a symbol by now. On a Mac, you have to right click and say create symbol. On a PC, you can do the same, but what's our shortcut? F8, yes. We should have that one down. And then we should also start to be realizing that our movie clips should start with a capital letter. Okay, so you should start to remember these things now. So remember to start him with a capital letter and then export for action script so that we can call him up in our code. And just say yes, make my class file for me. And then go ahead and delete him from the stage because we are going to add him through our code. That'll be our first step. So let's go ahead and make a class to run for our game. Remember to click off of everything and then the properties for the stage pop up. And in that class text box, we can name our game file. This will be our AS file, our action script file. Remember to name it with a capital letter and no white space. So I just put Space Invader, all one word right here with a capital S and a capital I. And then I'm going to hit that little pencil icon. It'll say, hey, I'm going to create that file for you. Okay, and then you have to hit the pencil icon again to get him to open it. And then I'm going to do a Control S and save it right away. Remember, the default location for where he's saving it is inside the same folder as our flaw file, which is where we want it to be. Okay, so we'll save him. And voila, we have our file which will run when we run our code, when we compile him. So we're going to add a player to our stage. So we're going to add him as an instance variable. And you can see in the documentation there are comments written in the code, and you should write out those comments so we start remembering things. Okay? So it's important that we start remembering some of these programming terms, that we're making an instance of the player object. We call it player, and he's an instance in our game. Okay. So here's our instance of our player object, which we're creating. And it's customary to make them private. I know sometimes we forget that, but we should make him private. Remember to name your variables with a lowercase letter, which is different than a name with an uppercase letter, which is our type name. So remember, with an uppercase letter, this is our class name that's creating the object. And when we do it with a lowercase letter, it's a totally different word. And so that's our variable name. So we create the instance of our player object as an instance variable. And then in our constructors where we instantiate that player object. Instantiates. Remember, we're instantiating the player object. That means we're creating him in RAM. This is what makes him in RAM for us. So we'll say our player equals a new player object. And so he calls the default constructor of our player class and creates him. All right. Now for now, I'm going to say player's X value equals 300 and player Y's value equals 300, and I want you guys to figure out what to put here to make the player at the bottom of the stage. And you guys should be able to figure stuff out like that by now. Okay? So I'm just going to hard code 300 in here, but remember that you can use the stage.height, player.height, and you have to calculate where to put him on the bottom of the stage. Okay? I bet you guys could figure that out. I left some of it undone this time around so that we could figure it out. So then we realize what we're doing. But remember that you do have to set his X and Y value to something, otherwise he'll appear in the upper left-hand corner of the stage. And then importantly, we have to add him as a child to the stage. That's what makes him appear on the stage. So remember that we write a little bit of our code, and then we save it, and we run it to make sure our player actually appears where we told him to. And he appears 300 pixels over and 300 pixels down. Remember that his XY position, his little crosshair is right here. So that's 300 by 300. That's the point where he's appearing. Okay. And I'll let you guys figure out what to put in here. You can either figure it out now or later, but I'm not going to figure it out for you. Okay? You guys have to figure that out. And you can look at your past games to kind of figure it out. Remember, you can use stage.stageheight, stage.stagewidth, and you can figure out where to put your player. And he should probably appear in the middle and the bottom of the screen. It's a good place to put him. Okay? Alright, so did everybody get their player instantiated? And I even put in here IE, making it in memory. Remember when we're instantiating him, that's what's creating him in memory so we can use him. Okay, start remembering things like that. So I'll kind of assume, unless people raise their hand, that everybody got the player to appear. Okay, so a couple people, so we'll push pause really quick here. And resume. All right. So now we're going to make our mouse event, and we're going to listen for the mouse event and move our player accordingly. Make sure you understand this code as you're writing it. So what we're going to do is we're going to use our mouse event. So if you touch or if you move the mouse over the Swift, it'll move the player. If you move him to the left of the player, if you move the mouse over there, he's going to move to the left. And if you move the mouse to the right of the player, he's going to move to the right. So he's a little bit different than our Pong game. We're not going to use the click. We're just going to use a mouse move event. Okay, so we're not going to listen. We're going to use the click event to fire our bullets. So we're going to use the mouse move event, and when the mouse moves over the Swift, it'll move the player. So that way we can have, you know, listen for more than one event. Okay, I put a link to the API here in our notes, and we should start getting used to looking at this API, just for a few things at least. So we are going to use this mouse event class. The class name is capitalized because it's a class name. And he's in the flash.events library. So that's important because we're going to import this library so we can use the mouse event. Okay? And if we look down here, we can also use these properties of our mouse event. here's a local X. Oh, no, sorry. We're going to use the stage X. So notice we can do local X and local Y, but we're going to use our stage X and our stage Y, which is the horizontal coordinate at which the event occurred in the global stage coordinate. So it's where we're moving our mouse, the X position and the Y position on the stage. So we'll have to use those properties. Okay. And we're going to use this event here, the mouse move event. It defines the value of the property of a mouse move event object. So we're going to use mouse move. So it's good to start looking at this API. It shows you, what you could listen for with that mouse. You could listen for mouse wheels, mouse up, mouse over, mouse out. Remember that we have access to all of these things that we can listen for. It's good to know that so when we start making new games or changing our game, we can do different things. Okay? All right. So let's go ahead and look at that code and write it. Okay. Okay, sorry. That's okay. So we're going to add this event listener here. Remember that we add our event listeners to our constructor. So that it'll start. So when our constructor is run at the beginning of our game, we could add this event listener. We're going to listen for that mouse move event. Okay. And then we're going to call this function that we're going to write. We called it onMouseMove. And the onMouseMove function, because it's a listener event, it has to have a mouse event as the parameter. So that's why it says E:mouse event. And then we have a couple of branches in here. And in the branches, we're saying, okay, if where we move the mouse on the stage, the X position is greater than where the player is currently, his X position, then go ahead and add 1 to his X position. That means we're to the right of the player and we need to move him to the right. Otherwise, we'll see, okay, if you're less than, so where we're moving the mouse is less than or to the left of the player, then we'll subtract 1 from his player's X position and he'll move to the left. Okay, does that make sense to everybody? All right, let's code that. Okay, see if you can code it without looking at it now. That'll be the determining factor. You kind of look at it and then you see if you can code it without looking at it, okay? Because we need to start remembering how to do some of these things. So remember that we're going to add the event listener in our constructor. So we're going to add this event listener to the stage because we're going to move the mouse on the stage. So that's why we say stage.addEventListener. Remember that the code complete can help you out here. And then we're going to listen to a mouse event dot mouse move, right? And we're going to name our function, I called him onMouseMove. Remember that you can name your function whatever you want. And I see onMouseMove kind of turned blue, which is not a good sign. What is it if it turns blue? It means it's a keyword. And because I was using Flash Professional Creative Cloud and here we're using Flash Professional CS6, I think there's a little bit of a difference. So I'm just going to name it onMouseMoved instead so he's not blue. So that way we don't have any errors. So I am going to deviate from my instructions a little bit and call it onMouseMoved. Alright, so we added that event listener to listen for when we move the mouse. Now remember that we can name our curly brackets so we put our functions in the right place. So remember I can name my curly brackets with these comments because we want to put our new function after the constructor function but before the end of the class. Remember that. Okay, we always want to write our functions in this area. And we always want to make our functions public, so we always know it starts with public function. That should be kind of obvious. What we named him is the same name that we used up here. Remember that you have to have the parentheses. And remember that because he's a listener function, he has to have this thing called a parameter, right? So he has to have that parameter, plus we're going to use this parameter. And that's our mouse event parameter. So this is the information that's sent to our function when it hears that mouse move event. So he tells us where the mouse is moving on the stage. He has that information for us. So we need him as a parameter. All right. So now we'll do our if statement. We'll check if the mouse is moving to the right of the player. And then move the player to the right. So it's good to write notes to ourselves so we can start remembering what we're doing in here. So remember that an if statement is always followed by our Boolean statement, our Boolean check. And we want to check to see if where we move the mouse on the stage, which is our event object stage X position, so that mouse move event stage X position is greater than the player's X position, so that means he's to the right of him. Now in my notes I went ahead and put a trace statement so that we could see the player's X position. Remember that trace statements are used just to kind of give us information or debug our programs. Okay, and I just put this trace statement in here so we could realize what was going on here. Okay. When I put loop here, I just realized this is not a loop, it's a branch. So inside the greater than branch, we should say, and then e.stagex. And then we're adding 1 pixel to our player, which is actually going to make him move really slow. Okay. So I could say inside the greater than branch. And I'm just doing this, remember, just to kind of realize what's going on. So we know what that e.stagex is actually giving to us. Remember that trace statements have no effect on your gameplay. So remember what this does, it adds 1 to our player's X position.
But wouldn't it only add 1 while you're moving the mouse?
Yes. Yes. Okay, so that's how we're gonna, I mean, you could program it different, of course. And we'll see how this works, and if you want to program it different, okay, that's fine. I always encourage you guys to kind of branch out on your own and, you know, do something different. Alright, check if the mouse is moving to the left of the player now. So this e.stagex is less than the player's X position. And then move the player to the left. And so if we want to move him to the left, we're going to subtract at least 1. And this is the less than branch. So I kind of copied and pasted it and then modified him so that he is doing less than inside the less than branch, and then I'm subtracting that 1 pixel. Now 1 pixel is not nearly enough probably to make a really fun game. So I'm going to let you guys kind of play with that number, that 1 in there. In fact, you could even make it a variable and make it move faster as you level up. Note that a lot of these numbers can be used as variables, and then, you know, when you level up. Oh, and very importantly, we went over that we needed that import. So we do need to import this library. Notice I got a syntax or compile time error saying it doesn't know what mouse event is. And he doesn't know what mouse event is because we did not import that library. So importantly, we need to import that library, and we saw in our API that he's part of the events package. And there he is, little mouse event right there. Okay, so we need to import that. That's important. Important to import. All right. You should be able to move the mouse, and when you move it to the right of him, that if statement's true. Okay, notice that he can go outside of the screen, so if you wanted to put that check, you could make him not go out of the screen, but he can only go out of the screen so far as you can move the mouse to the right of him. And when you move the mouse to the left of him, the second if statement is true, and he does actually move. Now notice if you stop moving the mouse, he does stop. So if you wanted him to keep going, you can use that code from your last game and kind of think how you would keep him going. Okay, so you can modify this if you want. But we're going to go ahead and notice also that it is doing our output statements there on the bottom, and it is showing us where we're wiggling our mouse. Okay, on the stage. All right. So probably 1 pixel is not nearly fast enough. You guys could figure out, maybe put 10 here or some other number. And remember that this would be a cool place to put a variable, make him an instance variable, and then change that number as the game gets harder. You can make your game level up. Yes?
How do you make that a variable?
Oh. If I wanted to make it a variable, it's actually pretty easy. Let's go over that. If I wanted to make it a variable, I would make it an instance variable so that way I could change him. I would call it like player speed or something like that makes sense, what I would name it. And I would make it a number. Okay, so I would declare him at the top as an instance of a number. And remember that I would instantiate him in the constructor, so same kind of methodology here. I would come down here to my constructor and tell him that he starts out at 10. And then in place of that 10 down here, I would just put player speed, because remember when you have a variable, it just replaces it with its value. And then later on, you know, I could change that player speed. Okay, maybe I could even start him out at 1 here. Then every time I go in here, maybe increase him by 1 so he'll go faster as we move along here. So remember that doing the plus plus, it'll add player speed to player and then add 1 to him. So then, okay, he's adding way too much. So notice he's moving way too fast now. I kind of messed up my game. So maybe not the plus plus. Or you'd have to have a check in here if the player speed gets to a certain point to keep him at that certain point. So if you wanted to leave the plus plus in here, just say, okay, if your player speed is greater than 10, then just set your player speed to 10. And in that way it will kind of keep him at 10, so he'll gradually increase and then stay at 10 pixels. So I could see, you know, you can't really see the increase all that much, but alright. But that's how you would make it a variable instead. So remember, every time we hard code a number, you could make it into a variable. You could even make this into a variable if you wanted to. Okay. All right. So that's how we got our player to move. Everybody got their player to move? Excellent. Okay, good. All right. Remember to write those comments in there to yourself, okay? So now let's move on to making our bullets for our player to shoot up at his enemies. And we're just going to make a single bullet object in Flash Professional in our flaw file. We're going to make it into a movie clip. And I'm just going to make a really generic looking bullet at first, and then we can change it to whatever we want, just like we change our players. Remember to export for ActionScript and to name that class the same name as your object or your symbol name. Okay, so that way it's easy to code. And I put here, did you name your movie clip with a capital letter? Okay, remember to do that. All right. So let's make our bullets. So I'm going to go to my flaw file to kind of design my bullet object. And you can make it a rectangle, or you can make it an oval, or you can, you know, later on you can make it an actual like missile or a heart, like the Neon Mason did, little hearts that flew up. You can make it into anything you want. Okay, I'm just going to go ahead and just draw out a weird looking oval. And I'll have that be my bullet. Alright, so just to get our code to work, draw out any kind of bullet. And then select that bullet and of course press your F8 key and make him into a movie clip so that we can add him in our code and so he can be animated. Okay. Important, remember to name this the capital letter and then export for action script. And it should default and name your class the same name as your symbol. So let it do that default. Okay. And then press OK. And then you can delete him from the stage because he's in your library as a bullet object. And you should see the AS linkage here. Remember that comes from, you know, exporting for action script, that little check mark. It actually does a lot for us. Okay, so we're going to do something a little bit different this time. And we're actually going to modify our bullet class. And you can do this with any objects class. And we just haven't done it in the past because we haven't really had a need to. But we need our bullet objects to remember something. So each bullet object needs to start to remember if he's on the stage or if he's not on the stage. Since we're going to reuse these bullets, we're going to make 10 bullets at first. And we're just going to keep on recycling these bullets. So if the bullet shoots off the stage, we'll put him into the recycle. We'll put him into like a recycle state. Okay? Or if the bullet hits an enemy, we don't want the bullet to stay on the stage or keep moving up. We want to put him in the, you know, been fired state, invisible state, I called it. So they're either in the visible state where they're firing up the stage, or they're in the invisible state where they're off the stage. Okay? So we need our bullets to remember that about themselves. It's much easier if we make this as a property of our bullet, whether he's invisible or visible. So we're making a new property for our bullet objects. Alright? So we're going to edit our class definition for our bullet to look like this guy here. Okay? So we're going to make a new class. Well, actually, we're going to let Flash make the new class for us called bullet. And we're going to make him have an instance. Each bullet object is going to have an instance of visible. And visible is either going to be true or false. If it's true, he's on the stage, and if it's false, he's not on the stage. Okay. Oh, you know what? I just realized I called him visible here, but we're going to call him invisible. And the reason being is visible is actually a property of a movie clip we don't want to modify. Okay. I just realized that I need to edit this. So we'll edit him. Just note that where it says visible, it's going to be invisible. But we'll make him right now. All right. So to edit that class and to make sure we have the right class, we're going to go back to our flaw file. We'll right click on our bullet and we'll go to properties. And then we're going to click on that little pencil icon next to my class. So that's going to let us edit that class file. And it says, hey, do you want to open it with Flash Professional? Say yes. And it opens up our bullet class. Now we'll want to save it right away, so put Control S. He'll want to save in the default folder where all of our other files are, and so we'll say save. And he'll be saved as bullet.as. Remember that that name has to match this name, which has to match this name. And now let's make an instance for every bullet. Okay, so this instance invisible for every bullet. So remember that this is our template to make a bullet. Every time we make a bullet, it comes here and uses this as like a little stamp out. It's like a template. Okay, so every bullet's going to have this property. Okay, so we can name it a private var, and we'll name him invisible. And we're going to make him a Boolean. Boolean means true or false. So a Boolean type has two values, either true or false. So true, he will be invisible, and then false, he's going to be visible. So true, he's invisible, and then false, he's not invisible, which means he's visible. All right. So in our constructor, we're going to set the default value for our bullets, and a default value for our bullets is that the invisible is going to be true. That means they're going to start out invisible. Now I can label my curly brackets. So this is the end of my constructor. This is the end of my class. And this is the end of my package. Because we're going to write a couple more methods in here so that we can use this invisible property. We're going to learn something called accessors and mutators today. So because he's a private variable, we're not going to be able to access him outside of the class. We can't access this variable outside of our class. Okay, and this is a common thing to do in programming, to make them private so that people can't go around there and play with your variables. So we need something called an accessor. An accessor method gives us access to the instance variable. So accessor methods always look the same way. Okay, they're always public function, and then it always starts with the word get, and then your object or your instance name. So get invisible. And he's going to return a Boolean type because he's going to return the invisible property. So when we want to access him, we'll have to use this method to get access to him. Okay, that's called our accessor method. Whenever you make class definitions in any programming language, usually you make an accessor method. Okay. And then we're going to make something called a mutator method. This lets us change our invisibility property. So it's good that we learn these. So we're going to change it to whatever we pass inside of those parentheses. So we'll change it to our parameter v. So if we pass it true, it'll set invisible to true. And if we pass it false, it'll set it to false. And let me make sure in my notes. Oh, I called it set to. Maybe I'll call him set to. Now it doesn't matter what you name your variables, just as long as you're consistent with your naming. Alright. So we have our accessor method and we have our mutator method. And then I created these two methods here. Function disappear and function reappear. Okay. Which, of course, disappear makes our bullet disappear. And how is he making him disappear? He's making him go way over here on the left of the stage where we can't see him. Okay? Which is a convenient way to make him disappear. It sets his X and Y value to way up here. Here's our stage down here. It sets him way over here. So he's just sitting there waiting. That's where our bullet holding place is. And then to make him reappear, we can set his X and Y value to these numbers that we're going to send in as arguments. Okay. So we're going to make another function in here. These will come in handy. So we'll call it the disappear function to make him disappear. And so one difference is I'm going to add invisible will equal true because he is going to turn invisible after this function. And what we're doing is for that bullet, we're setting the bullet's x value to -500 and the bullet's y value to -500, and that'll make him disappear because now he's way over here. Changing the opacity is not going to work. At first you might think, well, I could just change his alpha opacity, you know, his alpha to 0 and that'll make him disappear, but then he's still on the stage and he can still hit your enemies. So we actually have to remove him from the stage, and we don't want to splice him from the vector because again that's runtime errors. So a convenient way to kind of make him disappear is just to put him over here. Okay, that seemed like the best way to kind of get him to disappear.
Oh, would it matter if it's to the left or to the right?
No. Just as long as he's somewhere off the stage. So you could put positive 1500 or something, you know, as long as your stage isn't that large. So that'll make him leave the stage, and then when we want him to appear back on the stage, we're going to make a function called appear. So we have disappear and then appear. And we're going to have two variables that we're going to take in as parameters, and this will be where we want him to appear. So remember that we can send in our functions information, so we're going to send it where we want the bullet to appear. So I actually can copy and paste this if I wanted to. So he's no longer going to be invisible, so my invisible property is going to be false. And I'm going to set his x value to that value I passed in. So the value, the first value in my parentheses will be that new x. And then we'll have a comma, and then we'll have that second value will be our y value. So then we're going to tell our bullet appear here or appear here or appear here. We'll tell him, we'll send him those new x and new y values. So that'll make our bullet appear in the right place. All right, and we modified our bullet class. He's much better now. He can work like a bullet better now. Okay, because now we have these cool functions for all of our bullet objects. We can make them disappear and appear. And then we can check if they're on the stage, because you need to check if they're on the stage and not move them if they're not on the stage, and not check to see if they're hitting an enemy if they're not on the stage, and stuff like that. So did everybody kind of get what we did? We modified that bullet class. It's actually kind of cool. Remember, you can modify any of your classes for any of your movie clip objects, but we just never had a need to before. And now with our bullets, we kind of have that need to check if they're on the stage or not. This is a good way to kind of work it. And I'll be updating our, for some reason I forgot to copy and paste my new version here. So I'll update our notes in a second. Yes?
So would this also work for like the carrots and flappy bunny?
Yeah, you could do all of these things for all of these objects. Now remember that all of our objects, even our player object, has a class definition for him. If I wanted to look at the player's class definition, how would you do that? I would just right click, go to his properties, click on that pencil icon, and here's my player. Now do I need anything in here? Not as of yet. If I wanted to add, you know, something in here, I could. But just note that these classes are created for you. Okay. That's what it's doing when it has that little dialog box that pops up and it says, hey, the class path wasn't found, I'm going to create one for you. That's what it was creating. Alright, so hopefully that makes sense what we did. We made this template a little bit different. Remember that this is the template that is used every time a bullet object's created. Alright. Now we're going to do something really cool. We made a vector last time. We're going to use a vector to hold all of our bullet objects. Remember that a vector is a big box that we use to hold a whole bunch of objects together and treat them as one entity. Okay, so we're going to keep track of all of our bullets by putting them in this vector. And then we're going to tell all of our bullets in that vector to move up the screen if they are fired by the player and if they are visible. Okay, and if they're not visible, then we know that we could use them again to fire again. Okay. We're going to keep count of the number of bullets that the user gets to have. So we're going to make an instance variable to hold this number to keep track of how many bullets are being fired. So we're going to make this as an instance variable and then instantiate it in our constructor to 0. And I put you should know how to do this. So hopefully you do know how to do this. This should make sense to you and you should know how to do this. Okay, so if we wanted to make an instance variable of num of bullets of type number, you should know where to put that. Where do you put that? You put it where you declare all of your variables in your game. Okay? So private var, you can name it what you want, but I named it num of bullets. Remember to name it with a lowercase letter. And then he's of type number. Okay? So hopefully you've already gone and you're adding him. You know where to add him. Where do we add him? Hopefully you know. You add him where you add all of your instance variables. And if you didn't know that you added him here, you should figure that out, right? You should start remembering things like this. This is where we declare our variables. And then you should know where to instantiate him. Remember that you come down here in your constructor and make him 0. Yes?
So we're doing it in the main file? We're
Yes.
not doing it in the bullets?
Yeah, the bullet, we're done editing our bullet class. You can actually close him if you want. Our bullet class is complete. This is how we wanted him to look. So our bullet class is complete. And remember, it doesn't make sense to put num of bullets in the bullet class because the bullet class represents a single bullet. And num of bullets has to do with our game. So it doesn't have to do with a single bullet. It just has to do with our game. Keeping track of the number of bullets is a game variable. Okay? Alright. So we named that name of bullets, or made that variable num of bullets. We instantiated him to 0, or made him 0. Now we're going to declare our vector of bullet objects. I named the vector of bullet objects bullets. Remember that you can name it whatever you want. Okay, I named it bullets with an S to note that this is the vector. In a lot of books they'll say you have to name these singular nouns, but I think it makes sense to name him bullets. Okay. Now remember that we declare him when we declare all of our variables. So you're going to declare him, you know, where you would declare all of your variables, and you should start to know where to declare these things. Okay. So he's going to, you know, be a vector of type. So when you put colon, you'll write the word vector. And then a dot, and then the less than symbol. And then what goes in between that less than and greater than symbol is, of course, the object type that you want him to be. So remember that this is a class name, so it uses that capital B. Remember that that's going to be our movie clip or object type. And that's how we declare our bullets vector. But now we need to instantiate our bullets vector. Okay, so you can even copy this if you want. Save a little bit of typing. Alright, so we're going to tell it that bullets is assigned the value of a new vector of type bullet. And that's in here too. And then what we need to do, because he's a vector of new bullets, we need to make each bullet. So we have to declare and push our new bullets into our vector. Okay. So in this code here, I have a for loop. Remember how for loops work. This is our initialization action. It happens once. I equals 0 happens once at the beginning of the loop. I less than 10 will be our Boolean check whether we do the loop again. And then I++ is our update action. It happens at the end of each loop. So how many times is this loop going to iterate? It goes from 0 to less than 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it happens 10 times. Okay, 0 to 9 is 10 times. So we're going to make 10 bullets at first. If you wanted to make more bullets, you'd change that 10 to either a variable or change it to a bigger number. Okay, but we're just going to make 10 bullets. When we run out of 10 bullets, if there's 10 bullets on the stage, he will not be able to fire again. Okay, once they leave the stage, we do recycle them, then he'll be able to fire again. So this is a kind of a way to limit his firing, if you wanted to limit it. So we're just going to fill him up with 10 bullets. Okay, you should start to realize how these for loops work. If you don't, you need to go home and read your book, right? You should realize how these for loops are working. Okay, the initialization action, the Boolean check, and the update action. So every time, 10 times in a row, we're going to make a new bullet. So that first line of code there makes a new bullet object. We then push him into the vector. So now he's part of our vector. That's how you add him to the vector. Then we're going to make him disappear, because at first we don't want him to appear. We want him to disappear. Okay. And then we're going to add him to the stage. Now he's disappeared and added to the stage. That means he's waiting up here in the negative 500, negative 500. Okay. So see if you can write that code without looking at it, not looking at me. You should start to realize that, hey, I should be able to write this code a little bit without looking at it. You might have to double check, the syntax after, but you should be able to start realizing what this code is and how to write it, okay? So we made a new bullet, you push it in the vector, you make him disappear, you add him to the stage. Now, when he's added to the stage, remember he's disappeared, so he can't be seen on the stage, but we do need to add him here so that it makes our performance of our game work better. Okay. All right. So remember that we do that after we instantiate our new vector. So see if you can write it without looking at it. I'll write it too without looking at it. Of course, people say it's easier for me to write it without looking at it, but okay. Now notice I put bullet with no S, so this is different than bullets with an S, okay? So this is a single bullet, which I'm creating with that constructor in my class. So then I'm going to use that push function in my vector. I'm going to push my bullet object into my vector. And then I'm going to make that bullet object disappear. And then I'm going to add him as a child to the stage. So even though he's disappeared, he's at point negative 500, negative 500. His X and Y value are up there, but he's still on the stage, just out of the way. Okay. I might have done that in a different order. No, I did do it in the correct order too. So note that you can push and make him disappear in different order, and that's okay. But you do have to create him first. So remember that this loop iterates 10 times. You can even write notes to yourselves. Iterates means it happens. Iterates 10 times. So iterates is a programming term meaning that the loop executes 10 times. So it iterates 10 times, making 10 new bullets in our vector. So make sure you know what that code does. So that way later on you can modify it or use it to make a new game, right? Remember that you can use all these concepts to make new games. And anything that has bullets, this is how you would kind of create that. Alright. So we've created them, they're out of the way. You can even compile and run it to see if you have any syntax errors. Hopefully there's no syntax errors. If there's syntax errors, it'll come up in your compile errors down here. Okay, if you do have a syntax error, check your semicolon. Remember, no semicolons after for loops. Okay, none here, but semicolons after your statements. And then I drew a visual here, an abstract image of what the vector bullets will look like in memory. So we can start visualizing vectors. Data structures in programming, you do have to visualize. So remember that when we made a vector of 10 objects, their indices are 0 through 9. Okay? And each of these is its own bullet object, and they're stored together. This whole thing together is our vector. So our vector keeps track of each element by their index number. And this is a good way to kind of visualize a vector. Okay, so remember when we're working with vectors, get this visual image in your head of what we just created. Okay, we created this. It'll help us a lot. Alright, so now we need to add an event listener to listen when the user clicks or taps the screen, and then we're going to have our player fire a bullet. Okay, so I'm going to add this event listener. Where we add event listeners, you should know where to add the event listener. Where do we add our event listeners? In our constructor, right? You should know right away, hey, I know where to add this. We're going to listen for the mouse down event, which is our click. And then on mouse down, we're going to go ahead and fire some bullets. All right. So you can even copy and paste your other listener event and then modify him. We can do on mouse down. And then you can name your function here. And he did turn blue. I knew he was going to turn blue. I'm going to name it something different than my documentation. I'm going to name it fire bullet because that's actually what our function is going to do. He's going to fire a bullet. Remember that you can name your function whatever you want. So if I named it something different, you can name it something different, right? So we're going to write that fire bullet function. So this function will occur every time the mouse is down. So every time you have that left mouse down. So that way if you hold down the left mouse button, you should fire away. Alright. So we're going to write our listener function like we know how to do. Remember that he has to be the same name that we named him up here, and that he does have to take in one parameter of the event that he was listening for. That's how you have to write your listener functions. Remember, you can name your ending curly bracket. So that we don't get curly bracket mistakes. Alright, so how are we going to fire a bullet? Okay, so this one was a little bit, you know, it had to have a couple of if statements and a loop here. So let's go over how this is working, and it does make sense. Now first we want to check that there is a bullet to add. So only add a bullet if there is a bullet to be added. So if num of bullets is less than bullets.length. Remember that bullets.length is the length of our vector, and he's 10. Okay, so if the num of bullets that we've fired is less than 10, then we get to fire another one. Otherwise we have to skip this if statement and nothing is fired. Okay, so that's our first if statement here. So let's write our first one first. So first we'll check to see if there is a bullet left to be fired. So we have that check if num of bullets, because we don't want to start firing bullets out of our vector. There's no bullets left. So all vectors have this variable called length that keeps track of how long the vector is. So if he's 10 bullets long, then that'll be the number 10. And it's good to label that curly bracket, especially if we get curly bracket mistakes. It's good to label that. So first we check to see if there's a bullet left to be fired. Remember that if there is not a bullet left to be fired, it'll come here and just end, and then he won't fire anything. You can make an error message pop up. You can make him misfire. You could do something else if you wanted to, right? Now the next part here is we're going to get the next bullet in the vector. This is called a for each loop. A for each loop lets us iterate through every object in our vector. So the for each loop starts at index 0, goes to index 1, to all the way to index 9, treating each bullet in turn. Okay? So that's what the for each loop does. It replaces B with every bullet in our vector one at a time. Okay? So we'll get the next bullet in our vector. So we'll say get the next bullet object in the vector. So it's called a for each loop, so you write the word for each. And then var B in bullets. Now I could have named it something other than B, but I just named him B. And then you can put N for loop here. Notice we like to put lots of comments in here. Alright, so we're going to check every bullet in our vector. And what do we want to check? We want to say, hey, if you're invisible, then I can make you appear and then I'll break. Alright, so we're going to get that invisible property. Remember, if he's invisible, that means I can fire him. If he's already visible and not invisible, or not, yeah, if he's not invisible, it means he's already on the stage. But if he is invisible, it means I can fire him, right? So we're checking to see if the bullet is already visible on the stage. Okay, so right here we're going to check to see if the bullet is invisible. And if he is, then we can fire him. Okay, so make sure you know kind of what that code's doing. So remember that we wrote those accessor methods. Now we get to use one. Remember that gets our invisible property and gives it back to us. Remember it's true if he's invisible and then false if he was not invisible. So if he's invisible, we'll go ahead and get him. You can label that curly bracket. Alright. Now here's where I wrote some comments to you. Think where the bullet's X and Y position needs to be set to and set its position as the two arguments to the reappear function. I'm going to hard code 200 and 300. So all of my bullets are going to appear in the same place, but you should replace this 200 and 300 with something else. What should you replace it with? Hey, very good. You guys got that quick. So if you didn't get that, think about what you should replace it with. And I'm going to let you guys figure that out. If you didn't hear him, that's good. You can think about what you want to replace it with. But notice that I'm going to call the bullet's reappear function. That's the function I wrote. Remember, that's that cool function I wrote. Remember that this function takes in the new X and the new Y. and it sets that bullet's X and Y to that new X and new Y. Do you see how that's this function over here? So every bullet has this function up here. When I call up here, it sends in the new X and the new Y. It makes his invisible false, and it sets that bullet's X and Y to those values I sent it. Do you see how this is kind of a better way to do things? If you don't see right away why this is a better way to do things, you can try programming it without the invisible property. It's a little bit harder if you don't know if he's invisible or not. Okay? All right. So, we're going to set the bullet on the stage, make him appear. So we can say B dot appear. And we're going to set his X and Y. I'm just going to hard code some numbers, and you guys are going to replace those numbers with better stuff other than 200 and 300. Now you can try 200 and 300 at first just to see, but all of your bullets are going to stack up on top of each other, and you're okay. Until we make them move, it's not going to look like there's more than one bullet. But remember, they're all going to stack up on the same place unless you change it. Okay. But you can run him, and when you fire it, okay, notice that he does make 10 bullets, but 10 bullets are all being stacked on top of each other. And that's why it looks like they're not moving. Well, they aren't moving. So it looks like there's one, but there's really 10 of them. And remember that if I click more than 10 times, I run out of bullets. That if statement's false, it just doesn't do anything. Okay? But you should see, you know, that bullet appear at X equals 200, Y equals 300. And then if you change this to something, I should AV mute this. What could you change it to? You guys already told me. Well, one person told me. Figure out what you should change that to, so then he appears at different places. Where he should appear. He should appear like he's firing from the player, hint, hint. So he should appear like he's coming out of the player. So wherever the player's moving to, that's where you want the bullet to appear. But I wanted us to kind of think of these things today, so I left that part out. I didn't want to tell you. Oh, and then very importantly, we break out of here. I don't think we've used a break before. The way that a break works, this break statement here, when it reaches the break, it jumps out of the loop that it's in. So once we find at least one bullet that is not, once we find at least one bullet that is invisible, we make him appear, and then we get out of there because we don't care about the other bullets if they're invisible anymore. We've added our one bullet, we break out of that loop. Okay, so that's what that break does. Break gets you out of the loop. Because we want to leave once we've added one bullet, we leave because we've added our one bullet. We leave this loop, which then in turn leaves the function. Okay, so we do need to put that break statement in there so we just don't keep on making all the bullets appear all at once. Okay, so we do need that break in there, which tells us to leave the for loop. Okay, so remember to write lots of notes to yourself in here so we know how our code is working. Because we need to start being able to understand and read and write this code on our own. Okay? Alright. Let's make our bullets appear, and then that'll be a good place to kind of stop for today. But I think we do need to make them move, at least. I wrote down how the function works again inside of our notes, so you can read that again. Alright, so here's how we're going to get our bullets to move. To get our bullets to move, we need to have a clock, a timer. A timer is going to tell it, hey, bullets move up 24 times a second. We call this function. We're going to call our onEnter frame function to be our clock. Okay, so we're going to add this event listener and then write this function, and inside of this function another for each loop, and we just say, hey, if you're not invisible, go ahead and change your Y value to -5, and that'll move the bullet up the screen. And I put lots of comments in here, and you should write the comments too. Okay, but this is how we're going to get our bullets and everything kind of to move up the screen. Now see if you can write it without looking at the code. This this is good practice, and then you can go back and look if you need to, right? It's good practice to kind of realize what you need to program, try to program it, and then, you know, because we're getting better at programming, hopefully. And all right, so we'll add that event listener in. So remember to add the event listener is pretty easy. And we're going to listen for our on-enter frame event. So remember that's in the event library, the enter frame event, the enter underscore frame. And then we can call it on enter frame. Or we could say, or I guess we could just call it that. All right. Okay, let's create this function now. Remember that it has to take an event. It has to take in a parameter, sorry, of type event, because that's how our listener functions are made. Remember that you can label your curly bracket. Remember that we're going to loop through the bullet vector and move the bullets that are not invisible. The ones that are invisible we don't want to move. We want to move the ones that are not invisible. So what's cool is I can copy and paste this for each loop from down there. Right? Now in my code over here, I did put extra comments so you guys can write in those comments too. But pretty much what we want to do in this for each loop is say, hey, if you, Mr. Bullet, here we're using our accessor method. Now this not operator right here makes true false and false true. So remember, if I'm invisible, I'll be true. But I don't want to move the bullet if you're invisible. So I'm going to say if you're not invisible. Get it? Okay. So if you're not, so this is our not operator. Exclamation point means it changes false to true and true to false. So if you're not invisible, okay, and you can even write that in words, if bullet is not invisible, then what do? We move the bullet up the stage a little bit. Now what is a little bit? I say 5 pixels is a little bit. You could change this number, but you just say, okay, remember that it's minus equal to move up the screen, because, you know, increasing Y is down, decreasing Y is up in our GUIs. And that should move all of our bullets up the screen. Remember that this function, the onEnter frame function, runs 24 times a second. So this is going to run 24 times a second. 24 times, in each of those times, this for loop is going to complete itself. It's going to check every single bullet to see if you are invisible or not, and then move every bullet 5 pixels. So remember that this is going to happen 24 times a second. Okay, so our bullets are actually going to move. So you might need to change this 5 to something else. If you want them to move faster, you change it to a bigger number. If you want it to move slower, you change it to a smaller number. And if you want to control their speed, you can change it to a variable. You could call it like bullet speed, just like how we did player speed. Okay? So if I run him and compile him, actually I do have a compile error there. Oh, he's just yelling at me for my onEnter frame, but that's okay. That's a warning. So when I do fire my bullets, And we did something wrong because it's renewing all those bullets, which we might have done in here. Oh, we need to set his invisibility to false now. And maybe, did I write that in my code? We just need to set his invisibility to false. Where do we need to set his invisibility to false? When we fire him, actually we did set it to false here, right? When he appeared. So let me check our appear function. It does set the invisibility to false. New XY. Oh, you know what we forgot to do? I think what we forgot to do. We forgot to increase our num of bullets, right? Alright, I have to remember, I must not have copied my code correctly, but that's okay, we can fix him. So what's happening, and you can realize what's happening, is every time we go to fire that bullet, it's firing the same bullet over and over. It's firing that first bullet. And so what we need to do is increase our number of bullets. So whenever we fire a bullet, we need to say num of bullets plus plus and increase that number. And then make sure that we're not firing the same bullet. But you should see him kind of appear there. All right. So here in our code, when we find that invisible bullet, we'll increase the number of bullets. And I'll make sure to update our notes. So we do need to increase our number of bullets. Notice I did this in the if statement, because that's when we're actually firing the bullet. So that means that number of bullets did go up. And then right here is where we need to get the correct bullet to appear. Actually, that should get our correct bullet. Actually, so I was thinking, when we get invisible, he's getting if he's invisible or not. And when we make him appear, our appear invisible should change it to true. I mean, to false. So that this should be false for the bullets that have already been fired. So let me try to debug him. Well, you guys can try to debug him too. Because he shouldn't be recycling those bullets that have already been fired, because and And actually, he's not recycling all of them.
Do you have anything to make it invisible again?
Not yet.
Yeah.
Because then they won't get recycled. Yeah, I know. But it's kind of weird. What I'm wondering is that when I click again, the bullet goes down. Like the other one disappears from the stage. Like the other bullet should stay on the stage and keep traveling up. Did your guys' stay on the stage? Okay. Okay. They should stay on the stage. Like all 10 of your bullets if you click 10 times. And they should travel up the stage. But I think this is a good time to stop recording for a second. I did write in the notes how to figure out if the bullet has left the top of the stage. I write the code to do this within your for loop, and you should be able to figure this out. Okay, so I'm going to let you guys kind of figure out how would you check to see if the bullet has left the top of the stage. You are going to want to do it on your on-enter frame. I'll give you a hint. You do want to check to see if the bullet has left the top of the stage on the on-enter frame event. You're going to want to check it here in your for loop. Check to see if the bullet has left the top of the stage. So you're going to want to check it here. Okay. And then if it has left the top of the stage, what do you want to do? Change his invisible property to true. Or, in other words, make it disappear. Okay, so you can call your bullets disappear function. So once he's left the top of the stage, you can say bullet, you are disappearing. So b.disappear. Okay, and I'll let you guys kind of write that code because you should be able to write that code, especially if I told you where it should be. You should be able to write an if statement that checks if the bullet has left the top of the stage, and if it has, then you make him disappear. Okay? So this is a good place to kind of pause.